Hello, I'm Professor Rad, and today we're going to talk about ratios and rates. In the previous video, we introduced fractions as a way of sort of bundling an amount and a size together. So today we're going to formalize those definitions and talk about ways that we can express it. So let's begin with our first definition. A ratio is a comparison of two values. So there are four common ways that you might see a ratio written. One way is by using the word to. So 46 miles to 2 gallons is the example I have here. But you might also hear, like, if you're mixing like liquids together, you might hear something like, well, it's 2 parts soda for 1 part vodka, right? If you're making a drink, or, something along those lines. Or if you're mixing resin, it might be 2 parts of part A to 1 1/3 parts of part B, right? So depending on what you're mixing, you might have this ratio of how much of one thing matching with another one. So that word to could be used there. Another way that it's denoted is, instead of writing the word to, you could use a colon, and we would still say to there. So this notation, I would read exactly the same as I read these words. This would be 46 miles to 2 gallons. Now, the way that we're going to be seeing a lot is in this format. Looks like a fraction, just with words in it. And we're going to say as a quotient. So earlier, when we've discussed division, one of the ways that we can write division is using this division bar. And this works really nicely for ratios because you can kind of see, your numerator or your top number and your bottom number pretty clearly written out, your first and your second. So just like here, I would say 46 miles first and 2 gallons second. The same is true here. I would say this is 46 miles to 2 gallons. Or sometimes you might see the word per. So 46 miles per 2 gallons. That's probably how you might most often hear this. This would be like your gas mileage on your car. How many miles per gallon, or how many miles per hour is your speed. And another way that you might see ratios written, especially if you are going into programming, is by using an ordered pair. We'll also see these sorts of objects in the future when we go to do some graphing, but it's another way of writing the same concept, where I have 46 miles as a distance and 2 gallons as an amount of fuel. So all four of these are saying exactly the same thing. They're just saying them in different ways. So it just depends on sort of the discipline that you're examining in, whether that is, mixing, so perhaps like chemistry or baking, versus computer programming, or like you want to visualize stuff. So perhaps in art, you might see some stuff like this. Or if you're using it as a quotient, so when you're saying like rates, like how fast you're going or how fast you're using up your fuel. Okay? So depending on, the context, different terminology or notation can be used, but they really all mean the same thing. They are bundling these two numbers together. 46 miles is being related to 2 gallons. These two things are kind of joined at the hip. So let's go ahead and do an example of writing out a few ratios using these four notations. So in this example, it says, suppose a bowl of fruit, contains 4 apples, 3 bananas, 5 oranges, and 2 pears. We're going to write each of these ratios in the 4 ways. So we're going to use to, a colon, as a quotient, and as an ordered pair. So for part A, we want the ratio of apples to bananas. So since we want apples first, that's the number we're going to write first. So we're going to have 4 apples. And we're comparing that to the number of bananas. So 3 bananas. So that's one way, 4 apples to 3 bananas. Or instead of the word to, we could use the colon. So we could write that as 4 apples to 3 bananas. We could write it as a quotient. So we could write that as 4 apples per 3 bananas. Or we could write it as an ordered pair. 4 apples, comma, 3 bananas. Notice that in each of these notations, I've maintained the same order. So order is important when you're writing a ratio because the first number, whether that's the 2, the colon, or the ordered pair, the first number in this case is representing apples, or the top number in the quotient. And the second number or the bottom number is representing bananas. So you want to make sure you're maintaining the right sort of placement of things based off of how we're writing stuff. So let's continue with part B. It says the ratio of pears to oranges. So we have 2 pears. And for oranges, there were 5 oranges. So we can write 2 pears to 5 oranges. Or we can write that with the colon. We can write it as a quotient, 2 pears over 5 oranges, each time putting pears first, because that's how they requested the information, with pears first. Or as an ordered pair, so 2 pears, 5 oranges. Now, a common type of comparison is one that we'll see in part C here. This one says the ratio of bananas to the total amount of fruit. So a ratio of how many of something you're looking at to a total is really common kind of ratio that you'll see. So we know that there are 3 bananas. Let's find the total amount of fruit. So we have 4 apples and 3 bananas. So that's going to add to give us 7. Then we'll add the 5 oranges, so that'll give us 12. And then we add the 2 pears to get to 14. So we'll have 14 total fruit. So we had 3 bananas, so we can once again write our ratio like 3 bananas to 14 fruit, or we can use the colon notation. We can use our quotient notation, so 3 bananas out of 14 total fruit. And then in our ordered pair notation, and these parentheses are part of that notation, you do want to include them. So 3 bananas and then 14 fruit. So again, it doesn't matter what they're asking us to write the ratio of, just make sure you have the first thing first and then the second thing second. Okay, now there's a special type of ratio that is called a rate. A rate is a ratio in which the two numbers that you're comparing have different units. So again, think about how fast you're going. We have miles per hour. So the units first would be miles, and then hour would be second. So miles and hours are different kinds of units. They measure different things. So miles per hour is a rate. It's telling you like how fast you're going. So we're going to look at a few examples. We're going to write them as a ratio, and then we'll decide whether or not it's a rate. Because we're going to be using the quotient notation the most frequently in this class, I'm going to write them using the quotient notation, but you could use any notation here that's correct based off of what we've discussed. So for part A, it says, it took me 14 hours to drive 550 miles from my brother's wedding. we're going to write the ratio of the distance traveled to the time traveled. So I'm just sort of underlining or highlighting key words here. I'm going to underline these numbers because those are going to be useful. And then I need to know what order to write them in. So we're doing the distance traveled to the time traveled. So that means we want our distance first. So distance is the miles. So I'm going to put the 550 miles on top. And then the time is coming second. So I'm going to put the 14 hours second. So we have 550 miles per 14 hours. Now here we have miles up top and hours down below. So the units are different. So that means this is a rate. Let's take a look at part B. Part B says, I ate 6 pieces of chocolate bar, and the chocolate bar was divided into 25 pieces total. We're going to write the ratio of the number of pieces eaten to the total number of pieces in the candy bar. So I ate 6 pieces, and that's the first number they want. So the number of pieces eaten. So I'm going to say 6 pieces. And we're writing the ratio of the pieces eaten to the total number of pieces in the candy bar. So our candy bar was broken into 25 pieces total. So this is out of 25 pieces. So the ratio of the candy bar that I ate was 6 pieces out of the 25 pieces. Notice how the top and the bottom are both labeled pieces. So the units on the top and the bottom in this case are the same. If they're the same, that means it is not a rate. It's a ratio because we're comparing how many pieces we ate out of the whole thing. So it's a ratio, but it is not a rate because those units are the same. Let's look at one more that you might see in like a chemistry or science kind of class. It says the population of a bacteria colony grew by 150 bacteria in 1 hour. So grew by 150 bacteria in 1 hour. We're going to write the ratio of the bacteria's growth, i.e., meaning, in other words, the ratio of new bacteria to the time of growth. So they want the number of new bacteria to come first. So 150 bacteria came first. And we're writing the ratio of bacteria to time. So the time was 1 hour. Now when I compare my units, we have bacteria up top and hour on the bottom. So these are different things. So that means that this is a rate. All right, so I've got a few questions for you to try here. Write each of these ratios in the 4 different notations just to practice the notation, and then also decide whether or not these ratios are also rates. In the next video, we will start to define more specifically components of ratios that are written in quotient format, and we'll start to visualize those as well. So I hope you have a fantastic day, and I'll see you soon.